And welcome to Poli Sci 200A. So this is a class in probability for social science. And for this introductory lesson, what I want to do is give you my perspective on what the point of going to all the trouble to learn some math that many people think are hard. It's not typically what social scientists come to graduate school to do. Why do we need to go through all of this? Is it really necessary? I want to give you some evidence that I think shows what we get from it. And the answer, just to let you know where I'm going here, is that we don't do very well without math. Okay, I'm going to acknowledge right at the outset that the mathematical foundations of probability and statistics don't come naturally to many people. We have to really work to learn it. We have to do a lot of practicing. But what I want to say is that the fact that it's unnatural is a good thing about it, because the way we naturally think about uncertainty isn't so great. We'll be better scholars if we can overcome some of the natural fallacies that we're all prone to. Okay, so the evidence is going to take the form of classic experiments from psychology that were done, I think, mostly in the 1970s by Kahneman and Tversky. I'm sure many of you have seen this material before, but maybe in a slightly different context here. Maybe you were thinking about it as the sort of psychology being interesting in and of itself, and it is. But here I want us to sort of go through some of these classic experiments that they did in more of a kind of self-reflective way, that we're all prone to the fallacies that their work famously identified. So I'm just going to go through some slides that summarize some of their classic experiments. And I'll start kind of with one where it's sort of easiest to see the fallacy and work up to ones that are, in my view, a little bit harder to see. But the easiest one to see is this example. So all of these experiments sort of took the form of subjects are recruited, they're given something to read, some description of typically of people, sometimes other things, and then asked to make inferences about them. And the inferences sort of always involve thinking about something that we can't be really sure about. So thinking in terms of probabilities, odds, uncertainty. Okay, and so this first one, the scenario is about a woman named Linda. And what are we told about her? She's young, she's single, speaks her mind, she's smart, majored in philosophy. And okay, looks like Linda's kind of a lefty. She's concerned about discrimination, social justice, and participated in anti-nuclear demonstrations. Okay, so you're just kind of getting a quick snapshot of this person. And then the people who are the subjects in the experiment are asked, well, which is more likely? Is it more likely that Linda is a bank teller or that she's a bank teller and a feminist? Most people say that she's a bank teller and a feminist. And if you're just kind of sitting here listening, you might be thinking, yeah, that sounds right. She sure does sound like a feminist to me. Okay, so now take a deep breath and think about that, though. Is it possible to be a bank teller and a feminist without being a bank teller? No, it is not possible. Everybody who is both of these things is one of these things. Is it possible to be one of these things without being both of these things? Sure it is. Okay, so there's a right answer here. The right answer is this one. But this is the typical answer. And so this really is my favorite of all the experiments that I'm going to talk about today, in part because I've opened this class with this little presentation for years now. I've thought about it over and over again. I absolutely logically accept that this is the right answer, but there's still this little voice in my head saying, you just know that chick's a feminist, don't you? You know, it's very, very hard to turn off the part of our brain that wants to rely not on logic, okay, it's logic that's underlying the right answer, but on reacting to stereotypes. That's how human beings are, okay? That's, I'm not passing judgment on it. We all think this way. It is what comes naturally to us. But as social scientists, we really do not want our professional work, our inferences about how the world works, to be driven by casually accepting the stereotypes that we happen to have been raised. One other point I want to make before I'm sort of moving on to another one is sort of the nature of the stereotype that was being primed here. The very first couple of years that I started using this example at the beginning of the probability class, I actually changed it. I told the students that it wasn't exactly what Kahneman and Tversky said. I tried to update it a little bit. I said, oh, Linda's a gender studies major and she's kept the social justice part, but she participated in Occupy Wall Street. And even that's starting to sound a little bit dated now. But then I stopped doing that because I realized by kind of trying to bring the stereotypes closer to what feels naturally to us, maybe I was obscuring another problem with stereotypes, how completely contextual they are, and how with even a decade or so of distance from them, how much easier they are to see through. Okay. So as I said, this is my favorite. In one sense, it's the best one. It's the one that will work through the mathematical logic that really makes the fallacy pop out real quick, probably next week. But we've got some other experiments to look at, so let's look at them too. So here's another one. In this little scenario is about Steve. He's an American man, shy, withdrawn, orderly. He's polite, but not very social. So this guy's an introvert. Okay. And then we're asked, what's his most likely occupation? Okay. And again, you can kind of probably guess that most people will say mathematician or maybe librarian. That introvert stereotype tends to fit those occupations more than the office clerk. And so these are the typical answers. Okay. What those answers are not considering, though, is, there's a lot of clerks in the United States, really, really a lot. Universities employ them, and of course, business employs them. It's a very, very common job category. So common that I looked up these numbers, I don't know, probably about a decade ago. And obviously these are rounded, but these are sort of the rough magnitudes from the census of how many office clerks, librarians, and mathematicians there are. Okay, so 3 million office clerks, 3,000 mathematicians. It's a pretty big difference. So even if every last mathematician, all 3,000 of them are all polite, helpful, and little interested in people in social life, all fit this stereotype to a T. Every one of them does. And even if only, say, 10% of the office clerks do, okay? So if it's 10%, that would be 300,000, okay? You're still 100 times as likely to be encountering Steve the office clerk rather than Steve the mathematician. And I actually think that those assumptions are pretty extreme. I've known some extroverted mathematicians, and I've known plenty of introverted clerks, far more than 10%. So the deeper point here, I think, is not that people don't go around with these kind of statistics in their head. The deeper point is that most people don't even think about this aspect of the problem, that the baseline frequency of clerks is so much higher than the mathematician. We get this stereotype, it kind of clicks with our existing knowledge, and we just go with it with all this excess certainty. And again, it's how we are in normal life. I personally think that it would be better if we were less that way in ordinary life too, but we really, really don't want to be like that in our professional lives as scholars. Okay. Here's another one that I think Kahneman and Tversky studied, but they certainly didn't invent. It's about coin flips. So we're thinking here, presumably a fair coin that heads is at least as likely as tails. And the question is just which of these two sequences is more likely to occur. So most people look at this, this first one here, and it seems kind of fishy, right? The head, 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 tail, 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 tail. So you look at that and it's kind of makes you wonder. Whereas this one, heads, tails, this looks random. Okay. Another thing people might say when they look at this is that these long runs of heads should be kind of unlikely. Okay, if you've had 3 heads, isn't it time for a tails? So that's a very old fallacy going back many centuries. It's called gambler's fallacy. Okay. And it is the fallacy that says, oh, if we just had a bunch of heads, it's really time for that coin to come up tails. So, and it is something that seems kind of compelling. If you're thinking, well, it really is time for tails, let me tell you something. That coin doesn't know that it just came up heads 3 times. That coin is not keeping track. That coin is just every time doing what it always does, being acted on by gravity and its own composition in exactly the same way. The fact that there were 3 heads in a row doesn't change the fact that the coin is equally likely to come up heads as it is to come up tails. Okay. So the correct answer to this one is that they are equally likely. Each of the strings of heads and tails have 4 heads and 4 tails, and the probabilities are the same. Okay, this one is in my mind sort of the hardest to parse. I think no surprise to me that most of Kahneman and Tversky's subjects got it wrong. So here we're thinking about a town with a big hospital and a small hospital, and the big hospital means that there's more babies being born. Okay, so it says about 3 times as many. And in both the hospitals, they're saying it's on average 50% boys, but that varies from day to day. It's also kind of a dated example, like it's sort of focusing on gender as assigned at birth by authorities. So I'm not endorsing that point of view. It's some old work here. But the question about uncertainty here is one that's worth thinking about here. So what we're asked to think about here is which hospital, big one or the small one, do you think the percentage exceeds 60% or more often? So at which one are we more likely to be far away from the typical value? Okay, the small one or the big one? Here we look at Kahneman and Tversky's results here, and we see this kind of an even split between the number of people who say it's the large one, say it's the small one, and slightly more than those 2 groups together say that it should be the same at both. Okay, that's not the right answer. The correct answer here is that you're more likely to be far away from the typical value at the small hospital. So one way maybe to see that, and it's a strategy that works in lots of these kind of puzzling situations. Sometimes if you take an example to the extreme, the logic can pop out. So let's think about an extremely small hospital where only 1 baby is born a day. You're never going to get 50%, again, in this, outdated paradigm where you're either a boy or not here. Even then it would be, it's like, well, let me just stick with the example here. in that sense, what would be written on the birth certificate in this hospital in the 1970s would never be 50%. It would be either boy or girl at that time. So that's, as I say, that's the hardest thing to see. It's the logic behind what I'm saying will come latest in the course. If you've had statistics before, you might be thinking, is this the law of large numbers? It is a law of large numbers that's lurking here. It's also, to some extent, just even hard to parse the question. And that is another feature. When we start thinking about uncertainty, we know what it means to be certain versus being uncertain, but then when we get into the details of talking about how uncertain we are and exactly what we're uncertain about, and how observing something might change that, just keeping track of what the question's even asking can be difficult. And the mathematical framework helps us with that as well. Okay, so one more Kahneman story. This isn't an experiment. This is a story that he tells in his popular book, Thinking Fast and Slow. It's a great book. Totally recommend it if you haven't read it. But so Kahneman relates this story. He was a young PhD in Israel and had been asked to give some advice to the flight instructors in the Israeli army about how to better train their pilots, how to use what these smart young psychologists were learning about how other people learn to improve their instruction. So he's a young psychologist, and he's giving them what he's learned based on the accumulated knowledge of his discipline, that positive reinforcement is better than negative reinforcement, that studies show that you're better off praising your students when they do well than you are yelling at them when they do the wrong thing. And, guys who are the flight instructors, they're these old guys with lots of experience. Some of them are not buying it. And so one of them pushes back and says, I have heard this and I have tried this. And I've tried praising my students when they do well. And guess what? They do worse next time. And I've tried, yelling at them when they do badly, and guess what? They do better then. So what's the deal with your studies? Okay. The flight instructor what he's reporting is not exactly wrong, but there's a problem with his inference. Okay, the problem with his inference is what he's seeing probably would have happened anyway. Okay, if a student has the best practice flight they've ever had in their life, okay, that seems like that should be praiseworthy. Whether you praise them or not, they'll probably do worse next time because there's just some kind of random variation in how we do. And if they have the worst flight, the worst class, the worst test performance, the worst anything, you have the worst one of your life, next time you will probably do better just because of basic variation, okay? That the really extreme values are the least likely ones, okay? So the answer that, I can't remember if Kahneman gave this answer or not, but the answer that you would give in this situation is that it wasn't his praise that necessarily made them do worse. It was the fact that they did so unusually good when they got praised. And it wasn't the yelling that made them do better. It's because they'd done something unusually bad. So the effect that the flight instructor is seeing is not necessarily the effect of what we might, in modern lingo, call the treatment, whether he's praising them or yelling at them. The differences he's seeing are due to what we call regression to the mean, which is the idea that if something is really unusual relative to its typical value, next time it'll probably be closer to that typical value. Okay. And again, sort of thinking about how we would interpret this. Now, what Kahneman and Newell have said to the flight instructor is the evidence that Kahneman had in these controlled experiments. What controlled experiment means is that they randomly assigned some students to get praise. So the praise wasn't always going to somebody who was gonna do worse than they just done anyway, just by basic randomness, and the yelling out wasn't going systematically to the people who are going to improve. anyway, that whether you got yelled at or praised was just determined by chance, and that's a better way to do inference. Okay, so that's a overview of ideas that you will learn to be more comfortable with by working through the mathematics that underlie them. Because by doing that, you're going to be practicing thinking in a way that is less natural for all of us. We all have to learn, how to do math, and it can feel pretty weird at first. But once you're able to do it, it gives you an alternative to your natural way of thinking, a way to check your ideas that just bubble up and seem obvious to you, a way to step back and say, well, is the obviousness here due to logic and evidence that I can defend, or is it due to stereotypes and the kind of sloppy thinking that we all are prone to engage in? So this class is going to get you further along on that journey. As I said at the beginning, not only will learning probability make you better scholars, I do think it makes you a better human being, that by giving us a vocabulary and a set of tools to think objectively about when we're uncertain, what we're uncertain about, to acknowledge that and work with it, we do better than when we just assume that we know everything. It helps keep us humble and comfortable with being humble, and that also makes us better scholars. So I'm happy to be going on that journey with you this quarter.